Hi learners, welcome to online video lecture. In this video, we discuss about the congestion avoidance in the communication networks. So in the previous video, we have discussed about the congestion control. That is how to control the congestion occurrence of the network. But in this video, we discuss about how to avoid the congestion. Instead of controlling the congestion, there is a possible ways to avoid the congestion techniques by based on the probability. The congestion avoidance scheme allows the network to operate in the region of low delay and high throughput. Actually, it is the prevention mechanism, while congestion control is recovery mechanism. So this is the difference of congestion control and congestion avoidance. So in this congestion avoidance, we can avoid the congestion occurred in the networks by based on the previous history of the network congestion, or it is based on the probability. So by avoiding the congestion, we can increase the throughput of the network and also minimize the delay in the network. So congestion avoidance techniques uses the two methods. So first method is DEC bit, or simply it is called as DEC bit scheme. Second one is RED, random early detection. So in this video we have only discuss about these two techniques of congestion avoidance. So first technique is DEC bit scheme. So actually DEC bit means that destination experiencing congestion bit. DEC stands for destination experiencing congestion bit. So DEC bit scheme is fully depends on the receiver side, that is destination side. So in this method, we have add one bit. That bit is called as congestion indication bit. In each header packet, to provide the feedback about the congestion. So actually DEC bit is developed on the digital network architecture, that is DNA. So in this scheme, we have split the responsibility of routers and destination hosts. So by splitting the responsibility, here we can minimize the or avoid the congestion in the networks. So it is fully router based congestion avoidance method. So upon the packet arrival, the average queue length is calculated to avoid the congestion. That average queue length is calculated based on the last period queue length plus current busy period queue length. So if the average queue length exceeds the value of 1, the router sets the congestion bit in each arriving packet's header. So it is purely based on the probability. So if the average queue length is counted over the last busy period plus idle time plus current busy period. If the average queue length is exceeds the 1 means the router decreases the size of the congestion window exponentially so that the source machine can adjust the packet flow rate, and the source machine maintains the congestion window. It observes how many packets have to the congestion bit set to 1, because this congestion, if the congestion bit is set to 1 means the average queue length is exceeds the value of 1, so that the source can adjust the packet flow rate by checking the value of congestion indication bit equal to 1. So if less than 50% of acknowledgements have the decibits set, then increases the size of the window by 1 packet. Otherwise, size of the window set to 0.875 times of original value. So by this calculation, decibit scheme avoids the congestion bits, avoids the congestion in the network. Then second type of congestion avoidance is RED. RED stands for random early detection. The main idea is to provide the congestion control at the router for TCP communication. So random early detection is developed from the decibit scheme, and it was designed to work well with TCP. So random early detection notifies the sender by dropping the packets. So if there is any possible to congestion will occur in the networks, the RED techniques automatically drops the packet to avoid the congestion. So packet dropping probability is increased as the average queue length is increased. The moving average of queue length is used to detect the long-term congestion. It allows the short-term burst to arrive. So consider this diagram. It shows the random early detection technique. So already uses packet drop profile to handle packet discarding. This profile defines the set of dropping probabilities according to the level of queue occupancy, a minimum and maximum threshold. Let's look at this diagram. The minimum and maximum threshold are defined by the following method. That is, if the queue occupancy lies under the minimum threshold, the packet drop does not occur. Minimum threshold, that is queue length is less than the minimum threshold, means packet drop does not occur. If queue occupancy is lies in between the maximum threshold value and minimum threshold value, packets are dropped according to the configured drop probability. If average queue length is greater than this maximum threshold value of queue, then all the new packets attempting to enter the queue will be discarded. So based on this technique, already avoids the congestion. So it uses the two values, that is maximum threshold value and minimum threshold value of queue occupancy. So this maximum and minimum value is depending upon the average queue length. So based on the previous history of the probability, this mathematical value is derived, that is maximum threshold value and minimum threshold value. So there are some properties related to the RED. The properties are RED drops the packet before queue is full in the hope of reducing the rate of some packet flows. Drop of the packets for each flow is proportional to the rate of the packet flow. Then drop of the packets are spaced out in time, because the RED uses the average queue length. So that average is nothing but that is mean value of queue length. This mean value is calculated from the previous history of the congestion occurred in the networks, so that RED can tolerate the burst of traffic, packet traffic in the network. Random drops hopefully desynchronize the TCP sources. So these are all the properties of RED. Then the mechanism used in the RED is, so to find the average length of the queue, RED uses some formula. It is based on the weighted running average. The formula is average length is equal to 1 minus weight into average length plus weight into sample length. So when sample length of the queue, it is nothing but queue length each time the packet arrives. The weight parameter is in between the 0 to 1, because the weight parameter is depends upon the probability. So probability value is lies in between the 0 to 1. So I already uses packet drop profile to handle the packet discarding. So this profile sets the maximum and minimum value of threshold value of queue occupancy, as mentioned in the previous slide. So these are all the techniques to avoid the congestion. Thank you.